Hello and welcome to the 2024 Design Expo presentation for the Michigan Tech Aerospace Enterprise. Today we will be telling you a little bit about the Enterprise, going over the projects we've been working on, and what our plans are moving forward. The Aerospace Enterprise is a collection of undergraduate students that are collectively exploring the aerospace industry through various hands-on projects. The program is composed of majors from all across campus working together to design, build, and test multiple smallsat platforms. The enterprise has two primary objectives. First is to educate the future leaders of the aerospace industry by providing undergraduate students with hands-on space systems experience. The second objective is to advance U.S. space technology by solving real-world problems. Not only are these problems challenging, but they're also directly relevant to the current U.S. military and NASA needs. The program was founded by our academic advisor, Dr. Brad King, back in 2001. Since then, it has helped over 400 students obtain their undergraduate degrees from Michigan Tech. And as of now, we are currently home to 78 active members from over 13 different disciplines across the university. We are currently operating out of two on-campus facilities, those being the Clean Room and the Aerolab. We are actively funded by two well-known satellite companies, which allow us to successfully design and launch one satellite into space and support two more on the way. Speaking of the two satellites on the way, the Enterprise has two active missions, the Auris mission and the Stratus mission. Let's talk about them. Over the past few decades, space technology has advanced such that satellites can now take up less space than a loaf of bread. The decrease in mass and volume allows for cheaper rides to space, meaning that the space environment is now more accessible than ever. This increased accessibility has led to thousands of new active spacecrafts in orbit, creating significantly more traffic in space. And, as you may know, with automobile traffic, more cars on the road increases the risk of accidents occurring. This is also true for satellites in space, especially when it is difficult to be aware of other satellite activity. This increased traffic in space has created new risks for interference and created a need for new methods of constantly monitoring the space environment. The Aerospace Enterprise's response to this issue is the Auris mission. The Auris mission is a pathfinder mission whose goal is to demonstrate a low-cost platform capable of exploring the interference potential of geosatellites. This mission will feature a small satellite, comparable in size to a shoebox, that will measure the antenna beams of communication satellite to further characterize their activity in space. Modern communication satellites can both create electrical interference through interfering signals, or create a physical interference by colliding with other spacecrafts. The Auris mission will allow us to explore both of these interferences in an attempt to further understanding of space domain awareness. Let's talk about how we plan to do this. There are two main objectives for the Auris mission. First, called beam mapping. The Auris spacecraft will be flying through antenna beams of a target satellite, and as it does, it is going to be using an onboard antenna to measure the power of signals being emitted by the target satellite. After passing through the beam of the target satellite multiple times, we will be able to stitch together these power measurements and create a contour plot like the one you can see in the lower left-hand corner. The other mission objective is called multilateration. As Auris measures the strength of the target satellite's signal, it is going to timestamp when it receives said signal. Meanwhile, 3 additional ground antennas will receive the exact same signal, but at 3 completely different times. Knowing the location of 4 receivers as well as the time when they measure the signal will allow an operator to backtrack the signal to a target satellite and approximate the coordinates of the satellite in space. Having both the location of a target satellite and map of its outgoing signal will allow an operator to better understand the characteristics of a specific satellite in space and monitor its activity just by listening to its signal. With that, let's switch gears a little bit. Let's talk about the Stratus mission. The Stratus mission shall demonstrate an inexpensive, scalable architecture of a CubeSat. This CubeSat shall be capable of imaging clouds and generating usable data for validating and improving existing climate and weather models. In this video, you can get a quick glimpse of Stratus taking pictures of clouds in target regions. This will be completed through the mission objectives 1, 2, and 3. The Stratus mission shall register each pixel to a location on the surface of Earth with a fidelity adequate for research. Objects 1,000 meters apart or more with respect to ground shall be discernible within an image. And finally, the mission shall be able to determine the cloud fraction of images taken over land. So similarly to the Auris mission, this mission has various points of motivation for its completion regarding aspects of its cost, research, scalability, and education. This platform, depicted in the bottom right-hand side of our screen, is not only a sliver of the cost of a bus-sized satellite, but it can also be scalable upwards to increase the frequency of data collection. Nonetheless, Stratus will enhance the current climate research efforts by offering affordable means of collecting cloud data, as well as offering means for students within our enterprise to get hands-on experience with space engineering and spacecraft operations. So that was a little bit about our current missions, but how does an undergraduate student team design and build a satellite capable of doing these missions? Well, the secret is within the path that we call the space systems engineering, which is a concept of taking the project from its conception all the way to the final stages. First, we'll determine the mission, or what we're doing in space. Then we will move to the list of requirements for the mission. This will guide us into our design phase of the spacecraft, and after that, we will be able to procure the actual hardware and test it on ground. Once the testing is complete, we will be able to launch the spacecraft into space and start its mission. So where is Auris in this timeline? Auris is currently in the testing and the integration phase. After spending about 3 years in the design phase, these plans are now being put into action by ordering all the designed hardware, connecting them together, and testing their functionality on the ground. And that's what about the next 1 to 2 years is going to look like for Auris. As you can imagine, there is a multitude of different systems being involved in the spacecraft, from the power systems to multitude of sensors and actuators to a means of communication, and of course, the hardware needed to perform the mission. This is what we call our avionics group. After the completion of our testing and our integration campaign, the spacecraft can launch and begin its mission in space, which is expected to be in the early of 2025 or midway through 2025. So now let's switch it up again and talk about where Stratus is on that timeline. So we are currently in the testing and the integration, specifically the hardware procurement. So due to the generosity of the Michigan Tech community and its network of alumni, the Aerospace Enterprise was able to raise enough funds to continue the Stratus mission and return the spacecraft to an operable condition. The Enterprise has decided to start over. We're working a lot closer with vendors, and we've chosen to make this a successful platform for spaceflight, and we're currently working to procure hardware, and we're expecting a late 2024 or early 2025 launch date at the conclusion of our integration and testing phase. With that, that brings us to our conclusion. I'd like to thank everyone in the Michigan Tech community for being so generous, because we would not be here without any of you guys. So thank you all again. If you have any questions, feel free to reach out. And if you have any more interest, please look us up on social media. And with that, thank you guys.